Hi, Assalamualaikum. We want to present about Atterberg limit of casagrande method from code DCC 30112, which is Geotechnical and Highway Engineering Laboratory. We from class DKA 3A, and the lecturer who gave this assignment is Puan Nur Asyah binti Ahmad. Let me introduce myself. I am Nurul Abakis F2023 and my teammate is Nur Nabihah Uzma F2032, Shazvin Rush F1053. Objective: to determine the plastic limit and the liquid limit of the soil sample. Theory: the moisture content of soil can be classified into 4 different states: solid, semi-solid, plastic, and liquid. Each state represents a significant turning point in the soil behavior. These transition boundaries are represented as limit. As the soil moves from one state to next, the limits are as follows. Plastic to liquid is the liquid limit LL. Semi-solid to plastic is the plastic limit PL. And lastly, solid to semi-solid is the shrinkage limit SL. We use Atterberg limit test to measure cohesive soil sample and the transition limit to classify the soil at different moisture content. To find this limit, we use casagrande LL apparatus to find the liquid limit, and Terzahi 1/8 diameter criteria for plastic limit. We can use this understanding to correlate with other soil properties, such as plasticity index PI and compressive index CI. Apparatus: number 1 is plastic squeeze bottle, number 2 balance sensitive, number 3 spatula, number 4 groving tool, number 5 oven laboratory, number 6 moisture content, number 7 porcelain evaporating dish, number 8 toilet tissue paper.
Hello everyone, good day. So before I begin, let me start by introducing myself at first. My name is Shashwin Raj, son of Bhaskar Naidu, and my registration number is 01DKA20F1053, and as you all know, I'm from section DKA3A. So today, I'll be explaining the part of procedures and the process of making the casagrande method in Atterberg limits as well. So firstly, we should determine the mass of 3 moisture cans which we have prepared with the W19, and secondly, we should put some some gram of soil. Assume the soil was previously passed through a number 40 sieve, air dried, and then pulverized. Thoroughly mix the soil with a small amount of distilled water until it appears as a smooth uniform paste. Thirdly, we should adjust the liquid limit apparatus by checking the height of drop of the cup. The point on the cup comes in contact with the base should rise to height of 10 millimeters. The block on the end of the grooving tool is 10 millimeters high and should be used as a gauge. And practice using the cup and determine the correct rate to rotate the crank so that the cup drops approximately 2 times per second. So let's take a look the fourth procedure, the upcoming procedures in the next slide as well. Okay, now fourthly, we should place the portion of the previously mixed soil in the cup of the liquid limit apparatus. At the point there the cup rests on the base, squeeze the soil down to eliminate air pockets and spread it into the cup to a depth about 10 millimeters and its deepest point. The soil bed should form an approximately horizontal surface. Fifthly, use the grooving tool carefully and cut a clean groove down the center of the cup. The tool should remain same perpendicular to the surface of the cup as groove is being made. Use extreme care to prevent sliding the soil relative to the surface of the cup as well. Okay, nextly, we should make sure the base of the apparatus below the cup and the underside of the cup is clean of soil. Turn the crank of the apparatus at a rate of approximately 2 drops per second and count the number of drops and it takes to make the 2 halves of soil pad come into contact at the bottom of the groove along a distance of 13 millimeters, which means 1/2 inches as well. If the number of drops exceeds 50, then go directly to stop 8 and do not record the numbers of drops. Otherwise, record the number of drops on the data sheet. So seventhly, take a sample using the spatula from edge of the soil pad. The sample should be included the soil on both sides of where groove came in contact. Place the soil into a moisture can cover it. Immediately weigh the moisture can containing the soil, record its mass, remove the lid and place the can on the oven as well. So let's take a look at the next slide. Okay, now leave the moisture can in the oven for at least 16 hours. Place the soil remaining in the cup into the porcelain dish. Clean and dry the cup on the apparatus and the grooving tool. Remix the entire soil specimen in the porcelain dish. Add a small amount of distilled water to increase the water content so that decreased drops required to close the groove decrease. Lastly, repeat step 6, 7 and 8 for at least 2 additional trials, producing successively lower numbers of drops to close the groove. One of the trials shall be for a closure requiring 25 to 35 drops, one for closure between 20 and 30 drops, and trial 1 for a closure requiring 15 to 25 drops as well. Determine the water content from each trial by using the same method used in the first laboratory. Remember to use the same balance for all baking. So now let's take a look at the data and the analysis. Okay, now let's take a look at the data of this particular method. So firstly, we should calculate the liquid limits, the number of can, the number of impact, the can added with wet soil weight, and the can added with the dry soil weight, and the water weight, and the can empty weight, dry soil weight, and also the moisture content as well. So for the moisture content, we should add the can weight and also the wet soil and subtract it with the can weight and also the dry soil, and it should be divided with the can weight plus dry soil subtracted with can weight. So as you all can see, I have inserted a random data in my slide now, so you can see how they actually calculate the data as well. So in the end, we will calculate the moisture contains a percentage, which mean the mass of water should be divided with the total weight of solid mass and should be multiplied with 100, and we will get the end point. Okay, now let's see the analysis data, which is I have included the sample calculation. This slide is actually kind of previously same as the previous slide, but this slide should be calculated with the plastic limits as well. So here also we should calculate the number of the can added with the wet soil weight, the can added with the dry soil weight, water weight, the can empty weight, and also the dry soil weight, moisture content, and the average moisture content. So for the moisture content, as you all can see, there is the formula to add on the how to calculate the moisture content as well. And secondly, they also included the moisture contents percentage and their method as well there also. So lastly, we also should calculate the plasticity index, which LL should be subtracted with PL, and we will get the n percentage of the answer. So that's all from me. I will pass to my next teammate to explain their part as well. Thank you.
Discussion. The importance of the liquid limit test is to classify soil. Different soil have varying liquid limit. Also, to find the plasticity index of a soil, you need to know the liquid limit and the plastic limit. The value of this limit are used in a number of ways. There is also a close relationship between the limit and properties of a soil, such as compressibility, permeability, and strength. This is to be very useful
useful because as limit determination is relatively simple, it is more difficult to determine these other properties. Thus, the Atterberg limit are not only used to identify the soil classification, but it allows for the use of empirical correlation for some other engineering properties. Conclusion. The conclusion is another method for measuring the liquid limit in the Falcon test. It is based on the measurement for penetration into the soil of a standardized cone of specific mass. Although the casagrande test is widely used across North America, the Falcon test is much more prevalent in Europe due to being less dependent on the operator in determining the liquid limit. The importance of the liquid limit test is to classify soil. Different soil have varying liquid limit. Also, to find the plasticity index of soil, you need to know the liquid limit and the plastic limit. That's all from me and my team. Thank you.